InfinStor's mission is to accelerate deep learning to production. We do so using our machine learning platform that has some strong storage innovations. InfinSnap, which is fine-grained snapshots of cloud object stores. InfinSlice, which is an improvement on InfinSnaps, where you can get slices of data from a start time and an end time. We also do logical snapshots, could be pandas data frame, TensorFlow dataset, PyTorch dataset, etc. We are fully integrated with Jupyterlab for easy and familiar access. And finally, we employ MLflow, and we have extensions to MLflow for all of our machine learning operations activities. If you look at some of the risks in why deep learning projects are not going to production these days, you'll find that unexpected outcomes, predictions are not expected, fairness bias. These are problems because of insufficient data being used for training. InfinStor enables lightning fast iteration during model training with very large sets of data stored in S3 or some similar object store. We provide you the ability to do model provenance, proper model provenance by InfinSnap, which gives you snapshots of S3 bucket data at any point in time when you run your training. We also have excellent protection against data drift by means of doing InfinSlices against just either new data. If your machine learning algorithm is not capable of continuous learning or incremental learning, then you would use an InfinSlice with just the new data since your last training run and test to make sure that your data drift has not happened or your model has not moved away from the real world data. InfinSlice, in the case of algorithms that can do continuous or incremental learning, is even more interesting because you can take small slices of data, maybe 15 minutes or 5 minutes, and keep training your model against that. If you look at a typical workflow, you have a cloud object store, S3 or something similar, and you have InfinSnap and InfinSlice layered on top of that. You have the ability to build transforms, which are small pieces of Python code to transform or convert your data from raw data to some form of more consumable data. Once these transforms have been authored and extracted into our system, you can run them in a distributed fashion, a scale-out fashion. Then you have logical snapshots, which is basically the converted data before it's fed to your training algorithm. You can iterate on that several times quickly. You can do single node training to get started and then distribute the training if you want it to work on large sets of data. After that, you deploy the model, you have data coming in for inferencing, you do the scoring of the inferences, and you can iterate using InfinSlice on new data only or continuously iterate for incremental learning algorithms. This gives you protection against data drift. Take a look at our video demonstrating the capabilities of our system in Jupyterlab to get a better idea of how this works. This is a brief introduction to InfinStor Machine Learning Platform. Our primary user interface is through the Jupyterlab sidebar. Here you see our Jupyterlab instance, and on the left you have a set of icons. This is the file browser, the standard file browser. The bucket icon is the InfinStor platform's icon. If you press it, you have the InfinStor sidebar that comes up. You use your InfinStor credentials to log in. Once logged in, you can see the capabilities of the InfinStor platform. On the left, we have training data, transforms, scale out, deploy model, data drift protection, and MLflow. Training data is access to our storage capabilities such as InfinSnap and InfinSlice. If you didn't know already, InfinSnap stands for infinite snapshots of data stored in your S3 bucket. You can go back to the state of your bucket at any time in the past. InfinSlice is a start time. Given a start time and an end time, InfinSlice will give you the data that was collected in that particular time alone. Now with transforms, you have the capability to write small functions in Python, capture those, save those as transforms, version those for example, and then use those transforms against InfinSnap or InfinSlices of data, either small sets of data in your Jupyter IPython instance or scale out by running it in the cluster that's configured for you. Let me demonstrate how this works by showing you a small InfinSlice of data, about 15 seconds worth of data that was ingested into one of my buckets at midnight, between midnight this morning and 15 seconds past midnight. I've chosen the time midnight to 15 seconds past midnight. I hit browse and I choose the bucket BTC raw transactions, and I can go in and say auto generate read raw files cell for me. What this does is it generates a small piece of Python code, injects that into a new cell in your Jupyterlab instance, and if I hit go, this is going to start reading, listing the files, reading those objects, and storing them in an array. Once those objects are available, you can do further processing on those. Now, in this particular example I'm showing you, it's running in the IPython instance associated with this Jupyterlab. But with our capability to do scale out, you can run it in the cluster, in the cloud, or your own Kubernetes environment. Let's take a quick look at our MLflow integration next. You can see that the run that we just did, which consisted of loading the data from 15 seconds in the BTC raw transactions bucket, that particular activity has been recorded in MLflow tracking as an experimental run. If I press on it, it's going to show me some details. The only metric that I'm measuring is the number of objects downloaded. It's graphing those, and as you can see, these objects were downloaded in that period of time. So going back, you have the ability to manage large volumes of data in your S3 bucket using our training data capability. You have the ability to transform that data using our facility to capture it and apply the transform to larger sets of data.